In this video, we're going to be going over partial fraction decomposition review and going through an example. So the first thing that we're going to be going over is the transfer function, h of s, which is equal to the output over the input, y of s over x of s. And the first thing we need to think about is we need to get the transfer function into a strictly proper rational function, and this will allow us to do partial fraction decomposition. So the first thing you need to look at is the exponent on the numerator m and see if it's less than the exponent on the denominator, and that's n. The other two cases that we have is an improper rational function, which is m is greater than n, and then a proper rational function, which is m is equal to n. So now we're going to be going over the different steps in order to solve partial fraction decomposition. I'll split this up into 5 different steps. So the first step is to determine if the transfer function is a strictly proper rational function. Strictly. And then once we do that, we can factor and cancel out like terms from the numerator and denominator. And then we move on to step 3, which is to separate and multiply by the denominator on both sides of the equation. By the denominator. Then we have step 4, which is to multiply by the roots, and then we can cancel out some terms. And last step is to then convert the final equation into, or using the inverse Laplace to convert into the final answer. Okay, so now we will move on to the example. It's going to be a fairly easy example, but it'll show basically all the steps that we need to use. So we have h of s is equal to 7s minus 23 over s squared minus 7s plus 10. So we have step 1, which is to determine if the transfer function is strictly proper. In the numerator, we have an exponent of 1, and in the denominator, we have an exponent of 2. So m is equal to 1, n is equal to 2, and this means it is strictly proper. So step 2, we need to factor and cancel like terms. So since the numerator is already completely factored in its simplest form, we can move on to the denominator, which is s squared minus 7s plus 10. And this factors out to s minus 5 and s minus 2. So now we have 7s minus 23 over s squared minus 7s, s minus 5, and then s minus 2. Okay, now we can move on to step 3, which is separate and multiply by the denominator. So we have 7s minus 23 over s minus 5 times s minus 2. And we need to set this equal to the partial fractions. So we have a constant over one of the roots. So we have a over s minus 5, and then we have another constant b over s minus 2. So we multiply by the denominator on both sides. So we multiply this by s minus 5 times s minus 2, and then we are left with 7s minus 23 is equal to a times s minus 2 plus b times s minus 5. So the first thing we can do is we'll multiply by the roots. So the first one we have is s is equal to, we set this first term in a equal to 2 to cancel it out. So we'll say s is equal to 2. Yeah, add s right here. We just multiply it out and substitute 2 or s into 2. So we have 7 times 2 minus 23 is equal to a times 0, since 2 minus 2 is 0, plus b times 2 minus 5. Now we have 14 minus 23 is equal to 0 plus negative 3b. And simpling further, we have negative 9 is equal to negative 3b. And from here, we can figure out our constant b, which is 3. So we just do the same thing to solve for the constant a. So we can set this equal to, since s minus 5, we can use 5 and cancel that out. S equal to 5. Then we're given s times 5 minus 23 is equal to a times 5 minus 2 plus b times 0. So then we have 35 minus 23 is equal to 3a plus 0. And simplify, we have 12 is equal to 3a, and a is equal to 4. So now we just substitute this back into this equation, and then we can do the inverse Laplace. So we have 7s minus 23 is equal to our first term, which is a over s minus 5 plus b over s minus 2. So this is equal to 7s minus 23 is equal to 4, which is our constant a, s minus 5, plus b, which is 3 over s minus 2. And now we can do the inverse Laplace. So then we look at our table, and we have this form up here, 1 over s minus a is equal to EAT. So in this case, our a is 5, and we have a constant of 4, so we can take that out. So we have 4e, our a is 5, t, plus, and we do the same thing for the second term, which is 3e to 2t. That should be our final answer. And we just multiply by u of t, the whole thing.